In this class, I will explain about the application of Bernoulli's theorem in another device. Earlier class I had explained about the Venturi meter, which also uses the concept of Bernoulli's theorem on continuity equation. So the second one is the Pitot tube, P-I-T-O-T. Pitot is the name of the person who is responsible for this device. So it is a device used to measure velocity of flow in pipes or channels. So normally discharge can be obtained by multiplying the velocity by the cross-sectional area of flow. Q is equal to A into V. So if you know the velocity, you can multiply that by the area of flow. Maybe in pipes it is pi d squared by 4, or in channels it can be rectangular or triangular or trapezoidal, whatever shape it is. By knowing the area of flow, you can calculate the discharge as the rate of flow. So here the basic thing is, the principle behind this device, if the velocity of flow at a point reduces to 0, suppose if you make the velocity of flow at some section in a pipe or a channel, if you reduce the velocity to 0 by some means, the pressure at that point increases. So the pressure at the point where the velocity reduces or becoming 0, it increases enormously due to the conversion of kinetic energy to pressure energy. That is the reason why when the velocity is reduced, the pressure increases. There will be a conversion of kinetic energy, which is half mv square, to the pressure energy. Now based on the principle, this Pitot tube has been developed. Now here I am going to consider a pipe here. So in this pipe some liquid is flowing. The specific weight of the liquid is gamma. Q is the discharge as the rate of flow in this pipe. I will consider 2 points in this pipe, 1 and 2. 1 and 2 are the 2 points. At this point 1, a piezometer is in the inserted into the pipe. At the point 2, a bent 90 degrees bent pipe, glass tube is introduced. That tube is called as the Pitot tube. Now you can see here I have taken point 1 outside the tube. I have taken point 2 at the entrance of the tube. So what happens here? When the fluid flows like this, at this point 1 you will be having some velocity, whereas when it comes to point 2 at this section or at this point, due to the obstruction, the velocity almost it reduces to 0 at the point 1. Then it of course it flows through the tube. At the point 2, the velocity becomes 0. That means V2 you can always take nearly equal to 0. That according to this principle, when the velocity at that point 2 becomes 0 or reduces to 0, the pressure at that point will be enormous. It increases. That means P2 value. P2 is the pressure here. It will be increasing. So I will take V1, V2 as the velocity at 1 and 2. P1, P2 as the pressures at 1 and 2. P1 is called as the static pressure. Here it is called as the static pressure. So the static pressure at the point 1 is given by the level of the liquid in the tube, which is also called as the P1 by gamma. So in terms of pressure head, if pressure at 1 is P1, pressure head at 1 is P1 by gamma, where gamma is the specific weight of the liquid flowing through the pipe. Similarly, that pressure is called as static pressure, and P1 by gamma is called as static head. Please note that static pressure will be expressed in Newton per meter square, where static head is expressed in meters, where gamma is in Newton per meter cube. So we have learned that P is equal to gamma head equation earlier. Similarly, at the point 2, the pressure at 2 is enormous, and that pressure is called as the stagnation pressure, which is the higher value, which has got the higher value, and P2 by gamma is called as the stagnation head, which will be in meters. So there are 2 points here, 1 and 2. At 1 it is called as static pressure, at 2 it is called as stagnation pressure, or static head we can say, or stagnation head. So this is how we can explain the principle of Pitot tube. Now what we have to do is to derive the expression for the velocity. Normally it is used to find the velocity of flow. So I want the velocity V1 here. So because V2 tends to 0, V1 value we have to find out. When V1 value is found out, then we can multiply that V1 value by the cross-sectional area of flow to get the discharge Q or the rate of flow. Now to obtain the V1 value, I have to apply Bernoulli's equation between the points 1 and 2, sections 1 and 2. So as you know, Bernoulli's equation states that the total energy per unit weight of the liquid flowing or the total head at any point remains constant. So according to that, at point 1, the total energy will be P1 by gamma plus V1 square by 2G plus Z1. At 2, at the point 2, total energy will be P2 by gamma plus V2 square by 2G plus Z2. And if you take loss of head, it is HL. Now I have taken here Z1, Z2, the datum heads. What I will do is I will take the center line of the pipe. So this is the center line of the pipe. This itself as the datum. If I take this itself as the datum, then the value of Z1 and Z2 they will be equal, and that is equal to 0. And also if you neglect losses, then HL will be 0. So if you neglect losses, what is the expression we are going to get for velocity? It is nothing but a theoretical velocity, because actual velocity will be slightly less than theoretical velocity as we consider losses in calculating actual velocity. Now if you use these simplifications, Z1 and Z2 they are equal and they are equal to 0, and HL is also 0. So you will be left with only P1 by gamma plus V1 square by 2G is equal to P2 by gamma plus V2 square by 2G. Now from this I will just simplify like this. So here V2 is tending to 0. As you know, the velocity at the point 2, I can take it as approaching 0 because there is an obstruction to flow here. So the liquid particles will adhere to the walls of this tube, and almost you can say theoretically the value of V2 is 0. So this I can take it as 0, this term vanishes. So then P2 minus P1 by gamma will be equal to V1 square by 2G. Like this you are going to get. From the diagram you can see that this is P1 by gamma, static pressure at 1. P2 by gamma is the elevation difference from the center line, that is point 2 to this liquid level in the Pitot tube. So this is P2 by gamma. From the diagram you can see that P2 by gamma minus P1 by gamma will be your H. H is the difference in the liquid levels in the piezometer and Pitot tube. So that is the value of H. Now you can see P2 minus P1 by gamma is equal to H. So what you can write here is V1 square by 2G is equal to H. This becomes H now, or V1 square is equal to 2GH. So this is what you are going to get. So this is theoretical velocity because we are not considering any losses. So V1 square is equal to 2GH. Therefore V1 will be equal to root 2GH. Now this V1 I can take it as V because that is the velocity of flow in the pipe. So V1 is the velocity of flow in the pipe. Therefore V1 I can write it as V itself. So V1 I can write it as V. So V is equal to root 2GH is the theoretical velocity of flow. Now if you want the actual velocity of flow, it should be multiplied by a coefficient called CV, which is called as coefficient of velocity or coefficient of Pitot tube, whose value will be between 0.98 to 1. So 1 means there is no loss, that's all. So actual velocity is equal to theoretical velocity, but normally it can be 0.998 or 0.99 they may give. So this actual velocity is given by CV into theoretical velocity, that is CV into root 2GH. So this point 2 here is called as the stagnation point because velocity at that point is 0. Now once you get the actual velocity, you can calculate the rate of flow as the discharge Q is equal to A into VA. So this VA is nothing but the actual velocity. So here VA is nothing but CV into root 2GH. So A into CV into root 2GH, that gives the value of the rate of flow or the discharge. So this A value depends on the pipe or the channel section. So pipe, in the case of pipes, it is pi d square by 4 where it is the diameter of the pipe. Whereas if it is a channel, depending on the shape of the channel, so whether it is rectangular or triangular or trapezoidal, you have to calculate the area of flow, and that should be multiplied by the velocity to get the discharge. So here, so finally, by knowing only one value, that is H value, small h value, if you can measure the difference between the levels of the liquid which is flowing in the pipe in the two tubes, that is one in piezometer and one in Pitot tube. So if you measure the difference, so maybe for example it can be 20 mm or 30 mm, something like that. Just by using the data here, H value, you can come by knowing CV value and the area of the pipe, you can compute the discharge. So only thing is, if you want to know the velocity of flow in a pipe using a pitot tube, only we have to measure this. Only we have to measure the level difference in the liquids in the two tubes. That is the meaning. Now, of course, here the velocity will not be uniform. In the case of a pipe flow, the velocity will not be uniform throughout its cross section. So, what happens? A pipe is a circular cross section here. So, if Q is the discharge, so what happens if you take any section here? So, some section XX here. So, its variation of velocity will be something like this. So, velocity will be 0 at the boundary. At the boundary means at the walls, pipe walls, because the liquid particles adhere to the boundary, they won't move. Therefore, velocity can be taken as 0 at the boundary, whereas velocity is maximum at the center of the pipe. So, at the center of the pipe, velocity will be maximum. Please keep that in mind. So, at the boundary it is 0, at the center it is velocity. Assuming a parabolic variation of velocity over the section, so it can be something like this. So, this is a parabola you can take. So, maximum velocity occurs at the center of the pipe. Now, when you are calculating the discharge, so we have to consider mean velocity. Mean velocity means average velocity. So, here it is 0 here at the boundary and maximum at the center. So, what happens? Your mean velocity will be some percentage of maximum velocity. Maximum velocity occurs at the center. So, mean velocity will always be less than maximum velocity, or you can write mean velocity as some percentage of maximum velocity. For example, if it is 80% of maximum velocity, then whatever you are going to get from the Pitot tube equation, that is maximum velocity. Please note here Vmax, because Pitot tube is normally inserted at the center of the pipe. Whatever velocity you get, it will be the velocity at center of the pipe or maximum velocity. So, maximum velocity is given by Cv into root 2gh. From that you can get the value of mean velocity as some percentage. So, from percentage of if they give 80%, something like that. So, you have to multiply by 0.8 to get the mean velocity, and that mean velocity is used to find the discharge. So, please note that discharge is found out using the mean velocity, not the maximum velocity. So, maximum velocity is Cv into root 2gh. Discharge is equal to Q is A into V mean. So, A into mean velocity of flow. So, this mean velocity is a percentage of maximum velocity. So, what I mean to say here is, whatever value of velocity you get from the equation of Pitot tube, so this is called as the equation of Pitot tube. So, it is maximum velocity. So, from that you have to get the mean velocity. Suppose if they don't give any percentage, then you can directly use that maximum velocity only to get the discharge. But anyway, that will not be the actual exact discharge. So, in pipes, maximum velocity always occurs at the center, whereas at the boundary it is 0. Therefore, we use in this equation, in this discharge equation, Q is equal to A into V. Continuity equation, what we use here, this V is nothing but V mean. Please note that it is not V max, it is V mean. So, always V mean will be less than V max, some percentage, 80%, 75%, 85%, something like that they may give. That value of velocity is used to compute the discharge.